Okay, with our chapter 5, we talked about 5 different special segments in triangles, and we also talked about triangle inequality. So we're looking at different kinds of relationships with triangles. We're going to do a very, very quick review. It's going to go pretty quick. It's going to pause between solving for x. I'm not going to show the steps, so please make sure you're ready to pause the video as needed. The angle bisector, when we talked about the angle bisector, the one characteristic when looking at a segment and determining which is the angle bisector or is it an angle bisector is going to be congruent markings on the angle. So when we draw this, we'll just go ahead, an angle bisector has to come out of a vertex because it has to bisect the angle. We'll just go ahead and start at a vertex and go to the opposite side. And we don't know if we really bisected it or not because we didn't measure, but to let everybody know who's looking at it that these are supposed, we're going to treat them like they're congruent whether they look like it or not. We're going to put these markings. These are the only markings when determining do I have an angle bisector. Now with the problem here, we're seeing that if segment JL is an angle bisector, so we're going to pause at that comma and we look over here and say, okay, segment JL needs to be an angle bisector, so what do we need to mark? We need to mark the congruencies. Now with angle bisector, and whenever we have this angle bisector, unless we're using the theorem, then we're going to have basically one of two things going on when solving for x. It's either going to be a part equals part, or it's a part plus part equals whole, depending on what they give us. So the first thing they're telling us is that the measurement of angle IJL is 9x plus 5. So we look at IJL, we're looking at a part right here. Please label your diagram so you can see clearly what we're dealing with here. So here's 9x plus 5. The measurement angle KJL, so for K to J to L, is going to be 12x minus 19. So we have our two parts. We will be doing part equals part. Now, reading further, we need to see that not only are we going to solve for x, but we're also going to find the measurement of angle KJL. We go from K to J to L, we're looking at this part right here. So in the end, we're going to have to substitute in for x for the 12x minus 19. So to start off with, we have part equals part. So we're going to take the 9x plus 5, and we're going to set it equal to the 12x minus 19. So this is where, go ahead and write this down, get it paused, and solve for x. You should have gotten 8. If not, please double check your steps. Now we did want the measurement of angle KJL, so we're going to take KJL, the 12x minus 19. We're going to take out x, and we're going to substitute in what x was, that 8. And when we put this into our calculator, 12 times 8, and then we subtract 19, we're going to find out that the measurement is 77 degrees. If you plug it into the 9x plus 5, you will also get 77 degrees. The perpendicular bisectors, I tell my students, this is the longest name out of these four special segments that we're dealing with inside the triangle, looking for markings. It has the most syllables, it has the most letters. This has the most stuff going on with it. Your perpendicular bisector, we need to remember perpendicular right angle, or at 90 degrees. And the bisector tells us we're going to cut one of those sides in half. So we look at this angle bisector, sorry, perpendicular bisector. We need to pinpoint, just kind of eyeball right now. We're drawing it in where a midpoint would be. This is the bisector part. To let everybody know this is supposed to be in the middle, we need to put our tick marks. Your perpendicular bisector does not always come out of the vertex. It needs to be perpendicular or 90 degrees with the side where that midpoint is. So we can just kind of eyeball it. In this case, we will not have the perpendicular bisector go through the vertex. But we need to make sure, especially since we did not measure 90 degrees, put your right angle. That way we can say this is supposed to be 90 degrees. These are the markings you're looking for a perpendicular bisector. Find the segment that has a right angle as well as tick marks on both sides of that midpoint. Now, with the perpendicular bisector, the main thing we focus on is the perpendicular bisector theorem, and that's what this problem is going to be. Here we see that segment XY is a perpendicular bisector. We look at our triangle, and they already did these two markings, the perpendicular and the bisecting. They already have it there. And then we're seeing here that XW is 4A, so XW right here is 4A. If you don't like the letter A, change to any letter you'd like to. XZ, which is over here, is going to be 2A plus 26. We are going to find the length of XZ. I'm going to highlight it on the diagram too so I know exactly what to plug into. Now, these are not the congruent markings that we have for perpendicular bisector, but to remind you of what the perpendicular bisector theorem is, it states any point that's on your perpendicular bisector, okay? Segment XY is the perpendicular bisector, it's the one cutting the triangle, right? Any point on here we have point X, is going to be equidistant, the same distance from both endpoints, W and Z, creating at least an isosceles triangle. We have two sides that are congruent. So since we have two congruent parts, two things that are congruent, their measurements are equal. That tells us set these equal to each other. We will solve for X, and then we will substitute in, solve for A, and then we will substitute in for 2A plus 26. I went ahead and set up the substitution down here just like I did with the previous problem. I'm going to substitute in. We end up with 26 plus 26, giving us 52. All right, altitude. Altitude, there's one thing to focus on. There are no theorems. There's no, do I do part equals part? Do I do part plus part equals whole? What am I substituting in for? Altitude is all about right angle, 90 degrees, okay? Your altitude, just like the angle bisector, has to come out of a vertex. Perpendicular bisector is the only one that doesn't necessarily have to. With your altitude, has to come out of the vertex, and it needs to go to the opposite side perpendicularly, 90-degree angle. So again, from this vertex, kind of like with the angle bisector, we came out of the vertex, and kind of like perpendicular bisector, we needed to get it 90 degrees. Here, we're going to go from the vertex and just kind of eyeball where it looks like it might be 90 degrees. And again, if it's not perfectly 90, no big deal. Mine looks pretty good. We'll go ahead and put the marking. This is the only marking for altitude. Just like the only marking for angle bisector are congruent angles, the only marking for an altitude is that right angle. Now, like I said, it's all about 90 degrees. Here we have if segment EH is the altitude, so we know we have 90 degrees, so I'm going to go ahead and mark it. I purposely put it on the right side of that segment. We'll see why here in a minute. And the measurement of angle EHF is 4x minus 30. We're just going to find x. With altitude, 99% of the time, when you're solving for x, that's all you're going to do. I'm not going to ask you to plug it back in because we already know what the measurement is, 90 degrees. So here, angle EHF, it's to the left of this segment. I put the 90 degrees over here. We need to remember it is going to be 90 degrees on both sides. Perpendicular are going to create at least two right angles. Also, segment FG is a line. So that means these two angles are a linear pair, adjacent on a line. They have to add to 180 degrees. So now taking the 4x minus 30, we're going to set altitude, set it equal to 90. Go ahead and solve that, and we'll move on to the next one. Double check that you did get 30. If not, check your steps. All right, so in our classes at Katy High School in geometry, you're going to be keep mentioning all these different markings. You're going to end up with a triangle with 4 segments in them, all 4 of the angle bisector, perpendicular bisector, an altitude, and a median. You're going to have to tell which one is which. Okay, so this is the last one of those 4 that you're going to see a big old triangle with all of them in it. And again, angle bisector, find the segment that only has an angle bisected, the congruent marks. Perpendicular bisector, you have to look for the 90-degree angle that has congruent markings. Altitude, just look for the 90-degree angle that comes out of the vertex. Median, your median is going to be a special segment that goes from the vertex to the midpoint of the opposite side. So we'll go to a side and find a midpoint. Make sure we mark our congruent markings. And just like with angle bisector and altitude, it has to come out of the vertex. So we'll go ahead and trace that line, and this is what we're looking for a median, the segment that just has those 2 tick marks. With your median, like the angle bisector, you may have a part equals part, you may have part plus part equals whole. So looking here, we have that segment LJ is a median. So we'll go down here and see, okay, segment LJ, median, that means J is the midpoint, put our tick marks, and let's look at what we have. IJ, from I to J, is going to be 5x plus 24, so we'll go ahead and write that in. please label. JK, okay, that's the other part. That's going to be 9x plus 4. We're going to find the value of x and the length of IK. Be careful. Where is IK? I have really good responses in my classes. IK is the whole thing. We can't just substitute in and move on. Can't just solve for x and move on. We can't just substitute in and move on. We have to substitute in for 1 and double it. Okay? So we do have our two parts. So we have a part equals part. I'm going to move this up because I'm going to show my work at the very bottom. I'm going to write small. Part equals part. Set them equal to each other. 5x plus 24 is going to be equal to 9x plus 4. Okay, go ahead, pause the video. Solve for x. And we should get 5. If not, no, it's tiny, but check your work. Again, this one I'm going to go ahead and show all the way through with the substitution. It does not matter which one you substituted in for. I'm going to just go ahead and take the 5x plus the 24. I'm going to remove x. I'm going to plug in 5. 5 times 5 is 25, plus 24. We're going to end up with 49. Again, I want the entire thing, so we need to take the 49, and I need to multiply it by 2, so I can get the whole side, and we wind up with 98. All right, so your mid-segment, we're not going to give any diagrams with, median, altitude, angle bisector, perpendicular bisector, and a mid-segment, all of it, all in one triangle. But the mid-segment, what we need to focus on is the fact that not only are we going from a midpoint of one side to the midpoint of a second side, creating congruent parts. Let's go ahead and draw that in real quick. So here's a midpoint, congruent parts. Here is another midpoint, a second set of congruent parts. And then we'll connect those two. So the segment that I just drew in will be the mid-segment. I'm just going to put mid-seg. It will be, it doesn't look like it because I did not draw it perfectly, but the theorem, mid-segment theorem is what we're focused on solving, says that the mid-segment in the side, there's going to be parallel, but also the mid-segment is going to be half the length of the side, or another way to look at it is the side is going to be twice the size of the mid-segment. When I was telling my classes that they get switched around a lot, don't worry about writing this down, okay, because I'm going to erase this. But if I told you that the mid-segment was 14, looking at the physical size of the mid-segment and the side's bigger. So would it make sense to double that? Because all there is, when I give you a number value, you're either going to divide by 2 or multiply by 2. If the mid-segment's 14, would it make sense to divide by 2 and say this side is 7? No, because that side is clearly bigger. And say the mid-segment is 28. No, that is physically impossible. So if they give you a number on one of them, write in. They give you the mid-segment, write in the side length. Write those in so you can see, wait, does that make any sense? Now, with my students, I gave them this little makeshift formula when we have to solve for x. To find this, we're going to find mn, making sure we're seeing which one are we substituting in, okay, because they're not congruent. Mn is going to be the 2x plus 5. This formula that I gave my students, okay, is we're saying that your side length, so if we write down the side is going to be equal to, so I'll write it down here so I have more room, your side length right here, the 8x minus 18, equal to, here's your mid-segment, MID, the side length will be equal to 2, and then in parentheses times the mid-segment. So in parentheses, whatever the mid-segment says, 2x plus 5. When solving for x with the mid-segment problems, chances are you're going to have to do distribution. Okay, notice the parentheses on the right. The left side just comes down as 8x minus 18 equals. Distribution is multiplying 2 times 2x. All you have to do is multiply the numbers. 2 times 2 is a 4, and just bring down the x. Then we do 2 times a positive 5, so it will be positive 2 times 5 is 10. Okay, go ahead, we got 3 more steps to solve for x. Go ahead and solve for x, and then we will substitute in for the mid-segment of 2x plus 5. Go ahead and solve for x, plug it in, and solve for m in. Please pause the video now. That whole section. One is, if I give you 3 sides, is it even a triangle? Okay, so up here, this is not included in the notes. We could put, is it a triangle? And the rule is you just add any 2 sides together, and it has to be greater than the 3rd side. My rule of thumb with my students is I tell them take the small side plus the medium or middle side, the medium number. It has to be greater than the larger side. Again, that one's not, this is the little formula to look at. This one is not covered in here, we don't have an example. The next thing that we talked about was locating the longest side or the largest angle, locating the smallest side, the smallest angle, or putting them in order from greatest to smallest, smallest to greatest. So we'll go ahead and we're going to fill in some values here. Let's say that this angle is 20 degrees, this angle is 70 degrees, this angle up here is 90 degrees. We are either going to give you angles or side measurements. I need you to understand that clearly right now. We're not giving you both because you could see which number is bigger and smaller. But because we only have one triangle here, I'm going to go ahead and we're going to look at how no matter which way we look, we see that the smallest is across from the smallest, the medium's across from the medium, the biggest is across from the biggest. So here we'll go ahead and fill in some side measurements as well. And depending on which way we're going, if we have the sides or the angles, we look for the smallest one. And I always have my students write S, M's, and L's. Here's your smallest side. Okay, let's go find the smallest angle. Now, if I didn't give you the angles, let's look at the sides, the 11, 7, and 18. Well, 7 is the smallest number, so that would be the smallest side. And as you can see here, they are across from each other. So whether I gave you the 20 degrees and you have to know that the side over here is smallest, or whether I gave you the 7 inches and told you and you figured out that this angle is the smallest. Then we have our medium or our middle number. 70 is the medium size. And if we look at our sides, 11 was the medium size. So the mediums are going to be across from each other. And then 90 degrees is the larger angle, and 18 inches is the larger angle, so these two will be across from each other, the largest across from the largest. Again, we're only going to give you either the angles or we're going to give you the sides. You're not going to be asked to find the measurements of the largest, smallest, and medium sides. The third thing was finding the range. Okay, the range is pretty basic. Here are your 2 sides. We want to know what is the possible length. And we're going to write it in inequality, seeing here that x is going to be greater than some number and x is going to be less than another number. All we do with this, plain and simple, we're going to find the difference between the 2 numbers. So here I have my students write this. We have the difference, sorry it's sloppy, x in the middle, and then sum over here on the right. So you're going to take the 7 and the 10. We're going to subtract 10 minus 7, and we're going to get 3. Over here, we'll take 10 plus 7 to get 17, and here is your range. Also be on the lookout for what is the smallest possible whole number. Within this range, the smallest possible whole number is 4. It does not say or equal to, so it cannot be 3. The smallest possible whole number is going to be 1 up from here, 4. The largest possible whole number cannot be 17. The largest possible whole number has to be 16. Okay, so keep that in mind as well. And that is our very quick review on our relationships with triangles and these segments.